Hello, my name's GIles Favell. About 9 years ago I started experimenting with converting die-cast models to radio control for use on my railway, which was called the end of the line. I started using die-cast models to the scale of 1:43, 7mm scale, and motorising them with miniature gear motors, usually bought on eBay, and very, very small radio receivers with built-in ESCs, electronic speed controllers. And my aim was to get as realistic movement and motion in the vehicles so they could work with the railways, complementing the movement that you get with railways in as plausible and complementary fashion as possible. Initially, I thought I was going to be very lucky if I could just get a box van or lorry driving round with all the gubbins within the container on the back. However, I was able to more or less immediately create a vehicle where all the gubbins was actually hidden underneath or in the cab, and we could have a flatbed or drop side, enabling the lorry to actually do some real work, a real job of work. And this was really lovely, and it enabled the transfer of goods, it enabled carrying coal, this, that and the other, and really opened the door to sophisticated work on the railway. As I say, very successful. Very, very important that we achieved as realistic an operation and movement as possible. It's pointless having really lovely locos and stock moving round and then toy-like vehicles. The vehicles had to operate as realistically as possible and not stick out like a sore thumb. So I thought we'd have a look at some of these things and see a little bit as to what goes into them, and indeed how things have progressed a little as well. This is one of my latest models. This is a Bedford TK. It's actually again based on a proprietary die-cast model, although an articulated lorry, and I've just used the cab and scratch built the rear end of it, which is a fairly straightforward scratch building exercise. As you can see, we've got nice slow speed manoeuvring, very important, just as it is with a loco or something like that. Nice smooth running. And we've got a decent load bed at the back. And this particular one is a tipper lorry. With a locking tailgate, and the tailgate unlatches automatically as the bed rises. So this thing is quite capable of carrying around a load of ballast or stone or coal or something like that, and dumping it wherever it's needed. So obviously this thing has two motors in it, one traction motor and one motor to tip the bed. But as you can see, there's nothing particularly obvious or visible to the eye when it's working. As the bed comes down, there are a pair of latches at the back which rise and lock the tailgate shut to prevent any spillage. And then that's ready for the off again. Now, in the early days, I did experiment very, very briefly with innards of radio-controlled toy cars, and found that basically they were no use to me at all. They ran far, far too fast, and I couldn't do anything satisfactory with them. The top speed of this is around a scale 15 mile an hour. I'll just, in just a second, I'll whop it up to full speed so you can see what the top speed is. But of course 15 mile an hour is quite fast enough on a layout. I'll just go straight to full speed now. That is full speed. Now in reality, on a layout, that's really quite fast enough. The slow end is much, much more useful driving around a layout and looks much, much more plausible. The other really important thing on a layout is that it's just shunting out the way, but is that it should keep all 4 feet firmly on the floor, and it does that by having a rocking front axle. So you can see there, or you can if the light's in the right place, when I rock the model, the front wheel stays on the ground. This means if it's going over rough ground or what have you, it realistically keeps all 4 wheels on the ground, and it transforms the look of the model in use. You may be able to see possibly, let me lift it up, brake lights as well. It is perfectly possible to fit working indicators. I have to say it is not something I bother with, but it is perfectly easy to do if one is so inclined. Now then, when we started this game 9 years ago, these motors, which people are now quite familiar with, were not very well known. These are N20 gear motors, and they revolutionised what one could do. They are available in 3 volt, 6 volt and 12 volt. Immensely powerful, available in all sorts of different ratios, and I very quickly settled on 100-to-1 ratio and 6 volt as being appropriate for use in these models, and that gave a good realistic speed, and as I say, immensely powerful and quite small enough to hide underneath the chassis of these models. And let me just fetch the other half, as it were, and these then had these nylon bevel gears fitted to them. One to the back axle and one to the motor shaft, and these were very cheap. They're only 45p each, so very cost effective, and mechanically it was as simple as that, and very reliable, very effective. And that's how these things are driven. Through various models, I have ended up using some different motors. I made a mechanical horse, which you'll appreciate is a very, very much smaller vehicle than this this Bedford TK lorry. The mechanical horse is only as big as a very small car, and so those N20 motors would absolutely not fit in that. So another motor had to be found, and that other motor was this. This is a K20 gear motor. Now the K20 is much the same length as the N20, but a lot smaller. The N20 is 12mm by 10mm across its motor. The K20 is 8mm by 6mm across its motor. So it's a much, much smaller beastie. And much to my surprise, this little K20 worked very, very well in the mechanical horse. All the power I needed, and a very, very smooth action. Lovely speed response. So I started fitting it in other vehicles, and I fitted it in a Morris J-type van, in a Land Rover, in an Austin 7, all very, very successfully. So a very wonderful motor. That motor comes from China. It's nominally about 120 RPM output at 5 volts. So it gives me something like 90 RPM, just over 90 RPM at 3.7 volts, something like that. So that has become my go-to motor. Now, moving on to this beastie, I decided to make a tipper lorry just to see how I'd cope with the problems. The first thing I did was build the tipper mechanism, because that was the bit I hadn't done before. So the tipper mechanism is driven by a 6-volt motor, very small gear motor at the back here. And that is turning a lead screw in between the frames there. And on that lead screw, it's a 2mm M2 lead screw, and that is pushing a dummy ram, which in turn is raising the bed. Now, because of the geometry, the triangulation that is necessary when it's flat to lift it, that has to be sunk down between the frames. That also is the space where I would naturally put the drive motor. So I couldn't fit the drive motor where I would normally place it. The tipper mechanism is taking up all the valuable space. So I couldn't fit an N20 where I wanted to fit a motor. Indeed, there wasn't room for an N20 at all. I therefore had to try out of desperation fitting a K20 to a vehicle as big as this. And the only place I could fit a K20 was here. And indeed driving through a cardan shaft to a bevel gear up there. If you like, an act of desperation, driving a model as big as that with a motor as teeny as this. However, to my great surprise, not only does the K20 do it, it actually does it extremely well, and one can quite happily load up this vehicle and drive it. Whoops! I beg your pardon. And drive it around with no lack of performance. Let me be cruel. In just a second, as soon as the load's down. Nice big chunk of solder. Solder is heavy. This being happily driven about by that tiny, tiny K20 gear motor. Extraordinary performance, absolutely extraordinary performance. In consequence, I will never have any qualms about using one of those little gear motors. Absolutely brilliant. So generally I'm not likely to go back to the N20. The K20, however, is only made in one ratio that I'm aware of. Fortunately, it's a very useful ratio. It's also got a very, very short shaft. Not very well suited to these big nylon bevel gears. However, it is very well suited to these little Mod 0.3 brass bevel gears, and indeed that's what I tend to use with them. I have one here, and I've already fitted one of these brass bevel gears to that. Now this one by here is going into another one, another vehicle. Reason being, I've been looking, I've done a good number of 7mm lorries out of interest. That's another one that's going to get done in the very near future. But I thought I might have a go at a 4mm scale one. Now, other people have done 4mm radio control and indeed done some very sophisticated 4mm radio control, working cranes, even working high-abs. It's very big in Germany. There is, however, a tendency for some of these things to be a little bit racy, and it's partly down to the gear motors that are commonly used. And what I particularly wanted to do was to see if it was possible to make 4mm lorries with the same smooth, gentle characteristics that I've been getting with the big ones. So I bought an EFE model of a Bedford TK. And I bought a TK simply so I could do a direct comparison, having made a 7mm one. And I stripped it down and hacked the chassis about. Let me turn that on just a second. And please forgive the battery there. The battery will be going underneath the load bed there invisibly, but I'm still waiting on the correct battery and I haven't got it yet. But that's why the battery's just sat in the back. It will be invisible, so the load bed will be clear and available to work. So, slow speed running. We can do slow speed running with a 4mm one, and we can get good steering characteristics as well, apart from a bit of a slippy surface, because there's no weight on it at the moment. I do have some LEDs on order to fit rear brake lights to this as well. But it seems to me perfectly possible and perfectly reasonable to get decent scale running and scale performance out of 4mm as well, and also have a clear load bed. There are bigger models one can buy which would enable you to, if you like, do it mechanically easier. I specifically didn't want to buy a big, very easy model. I wanted to do a direct comparison, hence doing a Bedford TK. Now, again, this one, flat out, that's flat out, which is exactly the same scale speed as the other. And the reason is, it is exactly the same gear motor. It's exactly the same drive arrangement as the big one. And because it's the same ratio, and it's the same vehicle with the same wheels, as it were, the scale speed is exactly the same as its big brother. The ratio is the same, so the wheels are turning at the same RPM, therefore the scale speed is the same. So I'm quite happy that we can do decent 4mm radio controlled vehicles in exactly the same way. This also has a rocking front axle in the same way as its big brother. This one will not be a working tipper, I would say, because I'm a bit short of space for that. Now, one drawback with the 4mm ones is it is not possible to get the same size battery in. The 7mm one has a 650 milliampere hour battery in. Now that will work for in excess of 2 full exhibition days. This 4mm one I can only get a 180 milliampere hour battery in, and that will limit it probably to about 3.5 hours work, something like that. So in consequence, if I'm going to do anything with a show on this, I'm going to need 2 vehicles. So I bought another one, and yesterday I started chopping that about. This is the chassis of these things. It was a solid chassis, so here I've just carved away with a disc in a mini drill, and that gives me space to put the motor. I'd carved away a little space in there to clear the gear. There is a gear in there, yeah. Carved away a little space for the gear. I actually put a new piece of steel in there for the axle. There's a hole there for a charging socket, and up front a rectangular hole that takes the servo for steering. And this is the awkward bit. All this is, these notches have been carved away for the wheels to go into as the steering turns. I have yet to cut this slot out for the axle. Now, one of the problems you get with carving chassis about is when you're carving the slot for the rocking axle, you can inadvertently chop the whole chassis in half, which would be the case in this instance. So I've had to make up a plate, in this instance fairly thick nickel silver, to bridge over the top, and then using Devcon epoxy that in very rigidly to kind of rebuild the frame, rebuild the chassis before I chop the bottom out of it, simply to make sure the whole flipping thing doesn't fall in half when I slot it for the axle. The axles, if we can see the big brother here, rock on a centre pivot. I know it's black, you can just see the servo there, and a bit of wire forming a steering arm and a track rod there. One of the very, very important secrets, if you like, is the stub axle, which you might just be able to see there. The stub axle, which carries the bearing, is right, let's see if you can see it in there. The kingpin, which is the pivot for the stub axle, is tucked well into the wheel itself, so that when the wheels turn, they effectively turn on the spot, because if that bearing is too far in, then as the wheels turn, they will travel forward and travel back, and that looks unrealistic, and of course it will foul the body or foul the mudguards as it travels backwards and forward. So you really don't want that. If we have a look at the steering now, oops, We may need to have a look at it on the floor. There. But as it's going left, you can see it's... I may need to move the camera, bear with me. There, you can see the wheel is turning on the spot, not travelling backwards or forwards. And that's what we need. So that's the really important thing with that. And the other ingredient with that is bearings. All my front axles have, apart from the Austin 7 that is, have proper bearings. And these are flanged bearings. Oops, daisy, beg pardon. And for all the big vehicles, I use 2mm internal diameter flange bearings, and for the small vehicles, I use 1.5mm diameter internal diameter flange bearings. And that there, I don't know if you can see that, that's one of the older generation stub axles. That's what the Morris Commercial had and what the Ford Thames has, and indeed a couple of the other vehicles as well. I now do it a slightly different way, but we'll come on to that another time. So that's a brief introduction, not very brief, sorry. It's an update of where we are with some radio control vehicles and a little bit as to what's underneath them. I hope that's of some interest to you. Do let me know if it is. There will be a book out on the subject in the not too distant future. It's mostly written, which covers all this in a lot more detail, and that will hopefully be available from Wild Swan. But do let me know if it's of any interest. Thank you.